Alright, so today we're looking at Unit 8, Lesson 7, where our aim is to be able to rewrite numbers in standard form into scientific notation. Let's read our think about it. A googol is the largest number that a mathematician have a name for and is expressed as 1 times 10 to the 100th power. In science, a femtosecond is the smallest fraction of a second that modern technology can detect and is expressed as 1 times 10 to the negative 15th power. What can you say about a googol in a femtosecond? Why would someone express these numbers with exponents? Okay, I don't know about you, but I don't even know what those words mean. So let's break it down. Okay, so a googol is when I have 1 times 10 to the 100th power. Remember that when we're multiplying by 10 or 10 to the power of something, that's the same as adding or moving your decimal place over 100 times. So I would have 100 zeros behind that 1. Maybe you have enough time on your at home, but I'm not writing that out. That's way too much. So that's what a googol is. It's 1 with 100 zeros behind it. A femtosecond is when I have 1 times 10 to the negative 15 of a second. I guess I could write that out. Again, we're moving our decimal place over. So I'd have 1, and I'd move it over negative 15 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then you go in and fill in all those spaces with zeros. Look at how much space that takes up. Look how much time that took. That's a femtosecond. That's a tiny number. This is a giant number. I'm not taking the time to write out all those numbers. Oh my gosh, it's gigantic and so small. That's why we have what's called scientific notation. Scientific notation is when I have something, a number, let's call it A, times 10 to the power of something. So in googol's case, I have 1 times 10 to the power of 100. In a femtosecond, I have 1 times 10 to the negative 15. I don't have to write out my 100 zeros or my 15 zeros. I could just write out 10 to an exponent and call it a day. So what is the point of scientific notation? We can use scientific notation to do what? Instead of writing these giant numbers or these tiny numbers, what can I do? Go ahead, fill it out on your own. So we can use scientific notation to represent very large or small numbers. Today we're going to be going through and looking at how to convert into scientific notation, meaning how am I going to take these very large or very small numbers and make them something a lot shorter that's going to be easier to work with. Go ahead and get your key point down on your paper and then turn to your interaction with new material. Okay, so now we're looking at our interaction with new material. Example 1 asks, the temperature at the sun's core is approximately 2 million degrees Celsius. Express the temperature in scientific notation. First, let's again review what scientific notation looks like. When I have scientific notation, I have a number, let's call it A for now, and that number is going to be between 1 and 10. We're going to take that and multiply by 10 to some other power. That power B is going to be the number of times we change the place value. And that can mean either adding a lot of zeros after our number or moving our decimal place over to make it a really small number. So let's look at our number that we have. It says that the temperature is approximately 2 million degrees Celsius. First, let's figure out what our value of A in this number will be. 2. We have our number between 1 and 10. So we know that A in this case is going to be 2. Now let's figure out B. Well, when we're looking to find our value of B, let's look first at the number or the value of A that we found. I know that when I have a 2, my decimal place is going to be right after that 2. So up here in my original number, I can put my decimal place there. I'll have to move it over to become 2 million. So let's see how many times we have to change our place value in order to make our 2 become a 2 million. How many times did we have to move our decimal place? 6 times, which means that when I'm writing my value of B, I have 10 to the power of 6. We've now expressed our temperature in scientific notation. Now we're going to be looking at example 2. Example 2 says the average weight of a common ant is 0.003 grams. Express this weight in scientific notation. So like before, we're going to write our number down. And first we're going to find our value of A. Again, A is going to be a value between 1 and 10. So in this case, what is my value of A? 3. So I can go ahead and write 3 times 10 to a certain power. To figure out what power it's going to be, we need to see how many times we move our decimal place. So if my decimal place is here, after my 3 in my scientific notation, how many times do I have to move my decimal place over to be in the correct spot? I move 4 spaces to the left. If I'm moving 4 spaces to the left, is my exponent going to be positive or negative? Negative. When we're moving to the left, we're making our number smaller, which means that I should have a negative value. So my answer is going to be 3 times 10 to the negative 4. When we're going through and finding scientific notation, we need to have 2 simple rules. 1, find your value of A. And 2, find the value of B, which is number of times we're moving the decimal. So you guys can take these 2 simple rules and go throughout your independent practice and exit ticket to complete your work.